everyone. The angle stuff involving tangents and so on. And we got an elevator is rising at a rate of 10 meters per second. So we could easily draw that, couldn't we? Here's the ground. Elevator's going up at 10 meters per second. This is usually going to be the y. So dy dt, 10 meters per second. That's what I get out of the first line. David is standing 15 meters away from the elevator shaft when the elevator begins to rise. So David's probably right there. What is the rate of change of the angle of elevation of the elevator when the elevator is 8 meters off the ground? Well, David must be the guy that's looking at the elevator, and that theta right there is the angle of elevation. And so we want d theta dt when y equals 8. Set up okay? Comfortable doing that? Now it's got to angle stuff, so there's only one choice, SOHCAHTOA. Y is the opposite, 15 is the adjacent. So we only really have another one choice, that is the tangent of theta is y over 15. Comparatively, it's somewhat basic from what we've been messing with.
Are we ever going to have to do, like, cosine right there?
It's a possibility, but at this point, no. I mean, you just have to see what you got. There really isn't any difference in all of them. It's just what you'd probably hope it was a sine or cosine, because then your derivative would be a lot nicer than secant squared. So when I do my related rate, what's the derivative of y over 15?
1 over 15 dy.
The only thing I have to find is the secant of theta. Back here, the secant is the hypotenuse over the adjacent. Well, in the specific case here, y equals 8. That's 15. How do I find the hypotenuse? Pythagorean theorem, right? And I think it turns out to be 17, isn't it? One of those nice Pythagorean triples. So it's 17 over 15. So down here it becomes 17 over 15 squared d theta dt 1/15 times 10. Doing the math. 17 squared is 289. One of the 15s will cancel. So it's 150 all over 289. So I'm not sure what that turns out to be.
0.52.
0.52 in radians per